Okay guys, we're continuing on here. This is Unit 5, Day 2, Part 2. So we're on the last example 9 here. So we squared both sides. This removed the radical on this side, and then we had to actually FOIL this out. Some of you use Box method. Now I'm moving everything over to the right side to keep my x squared term positive, and that's going to result in 0 is equal to x squared minus 8x plus 12. So now I have to factor this. So I'm saying what two things multiply to a positive 12, but then would add to a negative 8. So it's going to be negative 2 and negative 6. So I get x equals positive 6 and x equals positive 2. Okay? It says, be sure to check your work and reject, cross out any extraneous roots, okay? If you were to put the original equation in your graphing calculator, you're going to see if there was 1 or 2 points that was actually accepted there. So if I look on my graphing calculator here, you're going to notice that the 2 gets rejected. Okay, that's an extraneous root, so x equals 2 gets rejected. So I'm only going to accept the 6. That gets rejected. Okay, mathematically, so what you could do in your graphing calculator, pay attention here. So f1 of x, so usually in your graphing calculator, f1 of x, you're going to put in your square root of 2x minus 3, graph that. You know that that's your little square root hill. Okay, and then in f2 of x, and guys, I'm just kind of rewriting what's already here. In f2 of x, you're going to put in your x minus 3, which you know is a linear line, and then you're seeing where they intersect, okay? They only intersect in one spot. So when x is 6, okay, so you know it's going to intersect at 6 something. To find the y, you're just going to substitute back in and see what that is, okay? So you're going to want to do that. Okay. All right. So now going back here to part B. Again, you got to isolate your square root. So I'm going to add 2 to both sides. And remember, guys, on this side, those don't combine because one has an x and one doesn't. So I get 2x plus 2 equals the square root of x plus 6. Now that I have that square root isolated, I could square both sides. So again, I'm going to be left with 2x plus 2. I'm going to write it out twice, so it's a little bit easier to look to FOIL, and that's equal to x plus 6. Okay, so first I'm going to get 4x squared, outers plus 4x, inners plus 4x, so I get plus 8x plus 4 equals x plus 6. So now I'm going to minus x from both sides. I'm going to minus 6 from both sides. So I'm going to be left with 4x squared minus 7x minus 2 equals 0. Okay, this is a quadratic where you do have a coefficient greater than 1, but make sure you can't divide out anything to remove that, but 4 doesn't come out of those two, so it's going to stay. So you either have to do the guess and check method, the AC method, or slip and slide. Okay, I'm going to slip and slide it, so I slide out the 4, and I'm left with x squared minus 7x minus 8. Okay, so now I'm going to factor that. I'm going to say what multiplies to a negative 8, but would add to a negative 7, and I get negative 8 and positive 1. Okay, so now I slip back in the 4 in front, so I get 4x minus 8 and 4x plus 1. Now I divide out this 4. If I divide them both by 4, I'm left with x minus 2. Okay, this binomial, nothing divides out, so you're left with 4x plus 1. Okay, split, and I get x equals positive 2 and x equals negative 1/4. Again, you must check both solutions back in, but again, you could put this in f1 of x, so that would be your f1 of x, that's linear, and this would be your f2 of x, and then see where they intersect. Okay, x equals negative 2, oops. Did I do something here with my signs? Let me see here. That'd be plus 8. Uh-oh. Something happened here. Did I factor something wrong? I did, guys. Right here. Here's my error right here. 8 minus 1 is plus 7. So that's a positive 7. Sorry, guys. It's going to switch all these signs over here. At least I could catch my error here to make sure I did something. So this is going to be plus 8 minus 1. So this goes plus, that goes plus. That would be negative. On this side, it's minus, minus. It would be positive 1/4. Okay, so negative 2 gets rejected. It's an extraneous root, so the only one I accept is x equals 1/4. Okay, again, verified in your graph. All right, last one here. I'm going to minus 4 from both sides. And I'm going to get the square root of x plus 2 is equal to negative 1. Square both sides, and I'm going to get x plus 2. Now remember, guys, negative 1 squared is positive 1. So now I minus 2, and I get x equals negative 1. Now, watch what happens when I do a check, and I want to check this by hand with you. Okay? If I check this by hand, if I go back to the original, I get negative 1 plus 2 underneath the square root plus 4, and I'm seeing if it's equal to 3. So this is going to be the square root of 1 plus 4. Is it equal to 3? You get 1 plus 4 equals 3. 5 does not equal 3. That means this gets rejected. And then you might say, well, what's going on? I have no solution. Okay, which is also known as the empty set or the null. You do not have to give me 3, you give me 1. Why should this make sense? Because when you put all of this left side in F1 in the graphing calculator, and then you know this is a horizontal constant in F2, what should happen? If there's no solution, it means they never intersect. So it should make sense that there's no solution because those two graphs never cross each other.